The marginal cost function is just the derivative of the cost function. So if we evaluate the derivative, sometimes it helps students to think of this as x to the negative first power. Look, this is the same thing. I haven't done the derivative yet. I'm just rewriting the cost function. It's 5x to the negative first power. And then that's, you could say that's 1/5 if you want, x squared. But both those are the same thing. And this is the same thing as this. So sometimes seeing that negative power can help with the derivative, because you know the power rule, the negative one comes down and multiplies. The derivative of a constant is just 0, so you can write 0 if you want, but no need. The negative one comes down and multiplies. That makes negative 5x to the negative second. And then the 2 comes down and multiplies to make 2/5. And then it's x to the first power. Okay, so that is the marginal cost function. Just seeing if I missed anything. I think that's it. Yep. So that's what you can type in for the marginal cost function. And then to find the marginal cost of 13 foods, all you have to do is plug in 13 into the derivative. So we're doing -5. And look, that's x to the negative second, or the same thing would be x squared in the denominator down here. So I'm going to plug 13 in to the derivative. And round your answer to the nearest cent, so we can use decimals. So we got 13 squared is 169, and 5 divided by 169 is, just got to make sure that's negative. I dropped my negative sign. Okay, there's the negative. Copy that to my clipboard. Now do 2 divide 5 times 13, convert that to a decimal. And I'm adding those two terms. That's what I get in my calculator, 5.17 to the nearest cent, $5.17. Then to find the actual cost, look, this is a continuous function, right? There's an infinite amount of points between x equals 13 and x equals 14 or some other points, right? It's an infinite amount because it's a line. But in actuality, we don't make half of a product, okay? So when they say the actual cost, they mean treat it like a discrete function. Find out the cost of producing that 14th item and subtract it by the cost of producing the 13th item. Okay? It's like a slope. You're calculating a slope here. And that's what a derivative is. It's just a slope between 2 points that are infinitely close. So this is, you don't have to, the 14 minus 13 is just to show you that it's the slope formula. Okay? So you're plugging in 14 in for the cost function. Up here, not the derivative, and you're plugging 13 into the cost function. Let me see. I can do that with my calculator. 5 divided by 14, that's the 200. Copy that. We got 14 squared, divide 5, plus that other answer. So here's my cost. I'll keep a bunch of decimal points. I didn't see what they wanted. And then we got to do 13. Plug in 13 into the cost function, not the derivative. So we got 13 squared, divide 5, plus that answer. So there's what we get with 13 squared. Round your answer to the nearest cent, so we can subtract those two. 239.5. So $5.37 it looks like.